Welcome to this tutorial on getting started with SDL2 in C++ using Visual Studio and vcpkg. If you're new to SDL2, it stands for Simple Direct Media Layer. It's a powerful library used for developing cross-platform applications and games, providing low-level access to audio, keyboard, mouse, joystick, graphics, and windowing. The SDL project has been around for 26 years and has been used in the development of many indie and AAA games. Before we dive in, it's worth mentioning that SDL3 is currently in development, but for now, SDL2 remains the go-to stable version. Let's get started setting up our C++ project in Visual Studio. And here I've launched Visual Studio Community Edition 2022 version 17.9.6. I'm going to create a new project. Make sure that I have C++ selected in my drop-down here, and I'm going to choose a console app to begin with. I'm going to give it a name. I'll call it First SDL2 Project. And I just want to make sure, because I'll be using vcpkg, to have this option selected for place solution and project in the same directory. And I will create my project. This gives me a standard Hello World project with a default mainline. I'm going to remove all of this to begin with. And before I go and replace the code, I'm going to bring in the SDL2 library into my project with vcpkg. Now, SDL2 is written in C, but it does work natively with C++, and it is part of the packages offered by the vcpkg dependency management tool. If you haven't worked with vcpkg before, I have an entire video on setting that up, and a link to that can be found in the video description below. Let's go to opening up the terminal. This opens up a developer PowerShell that I can use to add the SDL2 library to this project. If you haven't used vcpkg before, you'll need to type in vcpkg integrate install. I've already run that in the past, so I don't need to do that. It can't hurt though to run it multiple times. And then you want to set your project up for use with this dependency manager. So I'll run into vcpkg new -- application, and just making sure that I'm in my project root folder, which I am. That gives us if we take a peek in this directory, a vcpkg manifest file, which is a JSON file that lists the various libraries that we're going to be adding to our project. And now we want to add one of those libraries, which is vcpkg add port SDL2. And if we were to take a look at this JSON file now, we'd see that SDL2 is listed as one of the dependencies of our project. The final step for vcpkg integration is go to the project settings, and to make sure for vcpkg, we have use vcpkg manifest set to true, which will mean that that JSON file will be read in during our build. Now we can go and add a quick mainline to our application and just make sure that the project builds without any issue. So I'm just going to go to the build menu and hit build solution, or you could hit Control-Shift-B. You can see vcpkg kicking in here. It's going to go grab the SDL2 library, compile it along with our project. Hopefully that built for you without any issue, and we can now start coding a simple SDL2 application. I'm going to clear out my main CPP file here and lay out our plan for our example application. And so what we want to do step by step is first we're going to pound include the SDL library in this code. Then we're going to need to create a main function, which is going to serve as an entry point that matches SDL expectations. So SDL expects a particular function signature for our entry point. We're then going to need to manually configure our linker to include the SDL2 main library, and this is where SDL's entry point exists. So SDL actually sets up its own entry point for our application, which will then call our main line. After that, we're going to initialize the SDL video subsystem, create a window using SDL, create a renderer that we can render to. So we're going to render some 2D objects to this renderer, specifically a rectangle. And then we're going to start a game loop. And so this is going to be a loop that is just sort of executed over and over and over. And within this loop, we're going to pull SDL for events. This will allow us to look for the Windows quit event, but it will also allow us to look for things like mouse or keyboard input. We're going to, within this loop, clear the renderer, draw a rectangle to the renderer, display the contents of the renderer, and that loop will just continue on until the user decides to quit our application, at which point we're going to clean up after SDL and exit our application with a successful error code. And just to make note quickly of the error codes that we're going to use, a 0 is going to represent a success. And so often when we get back a 0 from any of our SDL functions, we're going to take that to mean a success. But also when we exit from our application itself, if we exit from our main line with a non-zero value like a 3, that will be considered an error. And if we exit with a 0, that will be considered a success. All right, let us begin. So with step 1 is the include file. And so we will just put here, just give myself some room here, and I'm just going to include, and inside of quotes, I'm going to include SDL2 slash SDL.h, and that is our header file. Include the SDL2 header file. As I mentioned next, the SDL library has its own entry point, at which point when that gets executed, it's going to call our mainline entry point. And because of that, our mainline needs to follow a very specific signature. So it needs to return an integer, and then with parameters, there needs to be an integer argc, and then a char star argv array. If you put in anything different here, you may get a compilation or linker error when you try to build your application. All right, after that, we need to configure our project to manually include the SDL2 main entry point. So I'm going to go to the project properties here. I'm going to go to the linker and specifically to the input section. And at the end of the additional dependencies here, I'm going to put in a semicolon and I'm going to type in SDL2 main.lib. So even though we used vcpkg to bring in SDL as a library, we still need to do this one manual configuration step for our linker. Otherwise, we will get a build error. Click OK here. And at this point, we should be able to test to see if all of that gets built correctly. So, and by all of that, I mean, manually linking that main line in and, properly executing our program here. And just for test purposes, maybe we will also include IOStream so that we can do just a little bit of cout with a hello SDL like so. So let's try compiling this. Looks like we get some errors, and let's see what they are. Cannot open file SDL2 main.lib. And this is likely just because I need to specify a location as to where to find that particular library. And so for this, we're going to go back into project properties. We're going to go to the linker and to the general section. And in the additional library directories, I'm going to paste in a very specific path. And I will include this in the video description as well. You can see this path starts with the dot, meaning the dot is the current working directory. And then we are pathing into the location where vcpkg installs libraries, specifically into this manual link subfolder. Back over here, we can run our application again, which will kick off the build process. And that built without error, and we get our console application saying hello SDL. Now that we've got all of the mainline stuff covered, it's now time to initialize the video subsystem. So we'll go in here, I'll remove my cout message. I guess I won't need my IOStream anymore here. And I will start by saying initialize the SDL video subsystem. And I'm going to note here that the SDL init function, which we are about to call, returns 0 on success. And so we're going to call this function right here, SDL init video. And as we say, it returns 0 on success. And so if there's an error, we want to log that. And so we can use the fact that in C and C++, 0 is going to be considered falsy, and any other number, any non-zero number, is going to be considered truthy. And so we're only going to get into this if statement if the SDL init is something other than a success, other than a 0. So if we get into here, we know that there was an error initializing SDL, and we can log that. There's a special SDL log error function that we can use. We're going to specifically pick one of the predefined categories of SDL errors that has been defined for us, which is the SDL log category application. And on this next line here, I'm going to put the string, which is going to be logged, could not initialize SDL, and then I'm going to put in a %s, which is going to bring in the next string into that string. What I want to inject here is the actual error message, and I'm going to get that by calling SDL get error. SDL get error. And not only do we want to simply log the error, we also want to return to the operating system a non-zero code to indicate that our application in and of itself resulted in an error. And most of the time in the example programs I've seen online that make use of SDL, the error code 3 is returned during this initialization phase if anything fails along with initializing the video or creating a window or a renderer. The next step that we want to go through is to set up the window and the renderer, and we're going to do it piecewise like this, where we'll first attempt to create those things, and if any issues occur, we will log them. From this point on, I'm going to just be copying and pasting bits and pieces of code so that you don't have to wait for me to type these things out, but I'll explain each one in turn. And so we're going to start by defining two const integers for our screen sizes. So this is going to set up the width and the height of the window that we are going to be creating. The window will be resizable, but this is going to be the initial size in pixels, which is 1280 by 720. And then down below here, we are going to make use of the SDL create window function to create a pointer to an SDL window variable. And so we're going to end up with this variable called window. We are passing to create window the title of the window. So this is what's going to be displayed on the window itself. And it just says hello SDL2. The next two arguments are going to be constants that define that we want this window to be centered on the screen. And then these are our constants here of the screen width and the screen height. And then a final argument to define that the window itself should be resizable. And if this fails, then the window pointer is going to be null. So we're saying if not window. So if it is a null pointer, I mean, we could even be a little bit more explicit about that. We could say if null pointer, then we're going to log an error saying that we could not create the window. I'm going to, again, quickly run this code here. Runs without error, but immediately ends because it'll create the window, but then it'll get to the end of our application. After creating a window, we need to create a renderer. And so the renderer is separate from the window. So the window is just going to be literally like I'm in the Windows operating system. I need to open up a window within Windows. And then the renderer is where we actually try to draw to. So when we use some of our 2D functions, we're going to draw a rectangle to the renderer, and then the renderer gets drawn to the window. So here we are creating a pointer to an SDL renderer with the SDL create render function. You can see the create render function takes in a window. So that's what is going to be displaying the renderer. And the other thing it's going to take in are some flags. And here I want to set up hardware acceleration. And I also want to have my renderer synchronized to the refresh rate of the monitor that it is being displayed to. So I want what's called vsync or vertical sync. And so if your monitor is displaying at 60 Hertz, then SDL is going to start rendering at 60 frames per second. And again, we're going to be testing, and again, I can make this a little bit more clear, if the renderer is a null pointer, meaning that this create step failed, we are going to log that out. And in both cases, we're again just logging out the actual SDL error. If we look up here, we are now at step number 7, where we want to start a game loop. And so a game loop is nothing more, in our case here, than a while loop. So I'm going to create a Boolean called running, which I will set initially to true. And then I can have a while running loop. And it's in this loop that we are going to sort of continually check for user input, render to our renderer, and display that renderer within the window. So those are going to be our final 3 steps, which is going to be polling for SDL events, drawing to the renderer, and displaying the renderer. In terms of polling for events, I'm going to create a event variable local to this loop of type SDL event, and I'm going to do a while loop. And what I'm going to do is I'm going to pass that event as a reference into the SDL poll event. And so what this means is I'm going to be continually calling poll event until there are no more events present. And poll event will return a 0 when there are no more events to process. And here inside of that while loop, I'm testing to see if the event type is of type SDL quit. And that means someone clicked like the X button on the window to cause our program to end. And even just with that in place, I should now be able to see our window for the very first time. When I run this, the window is going to appear on a second monitor of mine, but I'll drag it over. So let's run this. And there is our window. The other thing that is running at the same time is we have this console. And so actually 2 separate windows are appearing. This one, we can use IO streams or the func library to print out debugging information. And this one here is going to be our graphics window where we're going to be displaying a rectangle. Once we want to sort of package up and release this project, we can disable this extra console window because it's a little messy having it display as well. I've said that we want to display a rectangle, so before we get into our loop here, I will predefine an SDL rectangle or a variable of type SDL Rect. And what I'm doing here with the first two initialization arguments is setting up the location, the X and the Y location of where we want to place this rectangle. And I'm simply placing it approximately in the middle of the screen. It's going to be, I believe, the top left corner that is placed at that location. And then the next two values here are the width and the height of the rectangle itself. And then we want to, I'll just paste in a bit more code here. We're going to clear the screen, and we're going to clear the screen to the color red. So before calling SDL render clear, we're going to set the rendering color to red. And what we do is we call SDL set render draw color. We pass in the renderer, and then we pass in hexadecimal a RGB value, a red, green, and blue value, followed by a alpha transparency amount. And so here you can see we're just doing a full on or 255, which is hex FF for the color red and zeros for everything else, clearing the screen with that color. We're then going to set the active renderer color to blue. You can see RGB for blue here. We have the full FF value there. And with that blue color set, we can call SDL render fill rect. This will render a filled rectangle to the renderer, specifically the rectangle that we defined above being passed in as a reference. And then lastly, we are going to actually go and present that renderer to the window. So we're going to draw the renderer out to the window. And just to close up the application, outside of our loop here, outside of our game loop, which will exit once the user has clicked the X on the window, we want to sort of clean up after SDL. So we're going to destroy the renderer, destroy the window, and quit. So let's try running this application. Not the most beautiful application in the world, but here we are. We have a red screen with a blue rectangle being drawn to the screen, which is 200 width by 400. Let's just show you that I can change some of these values here. So if I go to my rectangle here, maybe I wanted it to be 400 by 200. And again, this is going to be the top left corner that is going to be here. So like maybe we'd want to do minus 200 to properly center it here, and then minus 100 to properly center it in terms of the height. Run our application. If we wanted to continually center our rectangle based on the newly resized window, that's not much more work. For that, we would need to ensure that these screen width and screen height are not constants, because we're going to change their values. And so up at the top here in our game loop, we're just going to paste in some code to fix this up. I can call get window size, passing in our window with references to the screen width and the screen height. Those are passed in as references so that they can be changed as out params by this get window size. And then we can change the rectangle's X and Y position to be the screen width and height divided by 2, and then a little bit of an adjustment to account for the fact that it's that top left-hand corner which is being used as the X and Y. So we're subtracting half the width of the rectangle from that X position and half the height of the rectangle from the Y position. And when we run our code now, we can resize the width and get it to recenter. We can resize the height and to get it to recenter, or we could resize both, and it will continually recenter within our resized window. We've now gone through all of our initial plan. The last thing that I wanted to show you was just a little bit more about the polling for events. So far, we're just polling for the quit event, but I wanted to show you that we could also poll for things like keyboard input or mouse input. And so we have like this if statement here. I'm just going to add to that if statement a few else ifs. So I will just paste in, and you can see here I've got a little bit of an error because I need one more Boolean variable here called user input, which I will initially set to false. And now what I've added to my polling here is if it's not an SDL quit event we're getting, well, maybe it is either a key being pressed, or a mouse button being pressed. So we can say here if the event type is any of the SDL key down events, meaning like any key on the keyboard has been pressed, or if the event type is SDL mouse button down, the mouse button has been pressed, we're going to set user input to true. And if we receive a key up event or a mouse button up event, we're going to turn that user input variable to false. And then to actually see this in action, we can change it so that it's not always unconditionally drawing the rectangle as blue. We can say like if user input go one color versus the other. And so it'll be blue when there is no input, and maybe we can set it to green. And so that will just be to change the green value there to FF and set the blue to 0. And now if we get any user input, any key press or any mouse button press, the user input variable will be set to true, which will change our render color before drawing our rectangle. And so here is our blue rectangle. I'm going to click on the screen, it turns green. I'm going to release my mouse button, it's going to turn blue, and then I'll try hitting a key on my keyboard, and that changes it to green, and releasing any key on my keyboard will change it back to blue. There's one last thing that you might want to know about, which is I had mentioned earlier that when we run our application, we get this SDL window, but we also get this console window. Now, this console window can be helpful for debugging purposes. And so if we're working on our application, it's not quite working the way we want to, we can print out to this console using a std cout or something along those lines. But as I mentioned earlier, you might not want to have both of these windows, especially if you were to release this application. What we can do here is we can change the profile from debug to release, and we can go into the project settings, and within here we're going to have to do some of the same setup that we did earlier. Specifically under the linker input section, we are going to put in a colon and say SDL2 main.lib. Within the general section under additional library directories, we're going to paste in this path that I showed before and which will be in the video description. And then finally, we're going to go to this system area, and we can change the subsystem here for our application from console over to Windows. And if we apply and click OK, when we run our application now, we simply get the SDL window, and we do not get the additional console window. That should be enough to get you started coding in SDL with Visual Studio and C++ in Windows. you can always consult the SDL website at www.libsdl.org for more information. The documentation can be found by following this wiki link. Within here, you can go to the tutorial sections and you can see a whole bunch of third-party tutorials for your continued learning on SDL2. In the description of this video, I will also post a link to a slightly more complex SDL example that I have posted up on GitHub. And this one, I'll just show you it running, similar to the one we just created, but this time we have a bouncy square bouncing around a scene. And if you hit any bit of user input, like the mouse or the keyboard, it turns from a blue square to a green square. So thanks for joining me today. And if you have any questions about getting started with SDL2 and C++ in Visual Studio 2022, let me know in the comments.